Namaskar. Now, in through the previous videos, uh, now we are familiar with what is the meaning of scalar vector and what are the three different representations of a vector physical quantity. Now, just to summarize that, I can represent a vector by a capital letter and bar on it. One way of representation is the magnitude and direction representation, whereas the capital letter without bar is the magnitude of that vector. Small letter and cap on it is the unit vector which represents the direction only, whose magnitude is obviously 1 unit. Second way of representation of a vector is the graphical representation or geometrical representation. I can represent this vector to be equal to, say for example, p bar. This is the vector whose length is the magnitude of vector and direction is same as the direction of vector. And suppose if I represent the vector like this, f bar is equal to fx into I cap plus fy into j cap plus fz into k cap, then this is known as the component representation of vector, where fx is the component of f bar along x axis, that is the unit vector is I cap. Fy is the component of f bar along y axis, that is the unit vector is j cap, and fz is the component of f bar along z axis with a unit vector to be k cap. Fine. Now today we will discuss the addition and subtraction of the vector. Now why the vector addition is not simple as the addition of a scalar. For example, if I say that 2 kg, suppose 2 kg wheat, and if I add one more quantity that is of 3 kg wheat in it, it will become 5 kg. In case of subtraction, if I remove 1 kg from that, it will be 4 kg. That means it is the addition or subtraction of just the number. The unit remains as it is. For example, 2 kg plus 3 kg is equal to 5 kg. Kg remains as it is. 5 kg minus 1 kg, it is 4 kg. Kg remains as it is. Kilogram remains as it is. Also, we have observed that it is not possible to add 3 bananas and 2 mangoes. No, it is not possible. That means to have the addition of two physical quantities, their units must be same. And this is obvious. 2 bananas plus 3 mangoes remains as it is. 2 bananas and 3 mangoes. It cannot be 5 banana, mango, etc. It is meaningless. Therefore, to have the addition or subtraction, the unit must be same. Only the addition and subtraction of the numbers is possible, having the same unit. But in case of a vector, we will realize that suppose if I travel a distance of 4 meter and then if I travel a distance of 2 meter, always it will not be 6 meter. If I continue with the same direction, then it will be 6. If I reverse the direction and travel, then the effect will be of 2 meter displacement. See, at the school level, we have observed what is the meaning of displacement and distance. If I travel a distance of 4 meter and then if I travel a distance of 2 meter, then total distance will be 6 meter. Total distance traveled will be 6 meter. But the displacement may not be 6. It may be 6 or it may be 2, or if it is inclined, suppose if I travel a distance of 4 meter along north and by taking a turn at 90 degree, if I travel a distance of 2 meter along east, say for example, in scholarship we have solved such type of problem, then we will have to use the Pythagoras theorem and then we will have to calculate. That means here the direction is important. I will have to mention that I have traveled a distance of 4 along north. If I continue, then it is 6. If I turn back, then it is 2. If I turn towards right, then it is root of 4 square plus 2 square, etc. That means we will have to solve it is root of 20, say for example. Means for the addition of the quantity having direction, we will have to have some laws of addition of vector quantities. And again we can say that there are certain laws of addition of vector quantities. Second thing is that those laws will depend in which representation we are representing the vector. Typically, if I represent a vector in magnitude and direction. Suppose one vector is a bar which is equal to a cap, and other vector is b bar which is equal to b into b cap, then the addition will be bit different. We will have to decide depending on what is the direction a cap and what is the direction b cap. Now in this case, suppose a cap and b cap are not defined properly, then the addition of these vectors is not possible. Correct? Therefore, we will have to have some addition in terms of angle. Later we will discuss how it is possible. But we shall begin with the direction representation or geometrical representation of the vector. Suppose this is p bar and one more vector, let it be q bar. It is represented by this. This is the vector q bar. And if I will have to add these two vectors, then I will have to recall one thing, that two vectors are said to be equal if their magnitudes are equal and their directions are equal. Therefore, suppose I will have to add q in p. What I will have to do, I can draw this p somewhere here. See, this p and this vector, they are same because their magnitudes are same. Length of the vector I have drawn same, almost same, and the directions are same. Therefore, this position of vector is immaterial. The vector remains constant vector. Vector remains same vector. Then there are two ways. Either I can move this q in such a way that the starting point of q, that is tail of the q, is lying on head of p, and I can place the vector q bar somewhere here. And then I can say that if this is vector p bar, then it is q bar, then a vector from tail of p towards head of q is known as r bar, and that is p bar plus q bar. Now this is nothing but the component representation. Suppose r bar is there, whose component along this particular direction is p, and along this particular, they may not be perpendicular to each other, but p r bar can be written as p bar plus q bar. Same thing we are doing here. If I am considering the vector f bar, then this is the vector, let it be fx bar, correct? This can be treated as the vector fy bar, and this can be treated as the vector fz bar. Here I will show you in previous figure. See, this can be treated as the ax bar. This can be treated as the ay bar. Therefore, I am considering ax bar, then I am traveling ay bar, and then I am traveling az bar, correct? Then I am traveling az bar. I will make this bold so that you will realize how it is addition. This to this, ax bar, ay bar, az bar. But what about ax bar? Ax bar is ax times I cap. This is a unit vector, and therefore I can consider this something like this. Okay. Now this is one way of addition of two vectors, and that is known as, it is referred as a triangle law of vector addition. If the vectors are represented in geometrical form, and if I will have to add these two vectors, form a triangle in such a way that two adjacent sides of triangle represents two vectors in cyclic order. This is important. That means q bar should not be from this to this, correct? It should be in cyclic order. Same, tail of q bar should start from head of p bar, and then the third side of that triangle represents the resultant of their addition in reverse order. Therefore, if it is in clockwise, p bar and q bar, then r bar should be from reverse, that is from the tail of p to head of q. One more possibility is there. Suppose if I draw this vector p bar somewhere here, I will draw it somewhere here. Suppose this, okay, I will use the next page. Okay, if I draw the vector p bar, but I will have to keep the reference as it is. If I draw the vector p bar somewhere here, this is also p bar, right? It is p bar, and it is expected because it is parallel to this. The magnitude is same, and therefore this p bar and this p bar are same. If I draw the q bar in such a way that their tails are together, therefore I will draw this vector q bar something like this. It is q bar, means instead of starting of the vector from end of p bar, the vector q bar will start with the starting of p bar itself. And if I draw a parallelogram with adjacent sides to be p bar and q bar, then the resultant will be the diagonal of parallelogram. Therefore, this can be treated as R bar. Correct? And again, I can write R bar is equal to P bar plus Q bar. Now, this is known as the triangle law of vector addition, and this is known as the parallelogram law of vector addition. What the law says that? The law says that if two adjacent sides of a parallelogram represents two vector starting from the common point, correct? Starting from the common point. Now, they should not be in reverse direction. Then, the diagonal starting from the same point represents the resultant of their addition. Now, see, as this is R bar, P bar plus Q bar, this is also R bar, P bar plus Q bar, result is same. Though if I implement the triangle law of vector addition or the law of parallelogram, the result will be same. But the physical significance is a bit different. If the events are happening one after other, that means if I travel a distance of P along P cap, this P bar means it is P along P cap, and then if I travel a distance of Q along Q cap, then it is better to use the triangle law of vector addition. The events are happening one after other. But suppose the events are happening simultaneously, that means if I apply a force of P bar on this object, and simultaneously if I apply force of Q bar, this is the P cap, this is the Q cap. If I apply the force, then the object will travel along this particular direction. It will follow the diagonal path. Here it will not follow the diagonal path, but the resultant will be same. Initially it will begin from this, it will travel up to this, then it will travel up to this, as if it is traveling along R bar, as if it is traveling along, because the events are happening one after other. But here the events are happening simultaneously. If I apply the simultaneous force P bar and Q bar along this object, then the object will follow the path along R bar. Okay, let it be. Therefore, these are two ways to add the vectors if they are represented in the graphical form, that is the geometrical representation of two vectors. Now, if the vectors are represented in their component form, then again I can say that suppose this F bar is there, and I will say that one more vector is G bar is there. Therefore, I will write it is Gx into I cap, plus I will write it is Gy into J cap, plus I will write it is Gz into K cap. Correct? Two vectors are there. Then what I will have to do, if I will have to add these two vectors, then actually it is very simple. I will write the H bar is the addition of F bar and G bar. Therefore, if H bar is the addition of F bar and G bar, then I will write it is Fx into I cap plus Fy into J cap plus Fz into K cap, plus I will have to write Gx into I cap plus Gy into J cap plus Gz into K cap. Now this indicates that initially I have travelled along x-axis a distance of Fx, and later I have travelled a distance of Gx along x-axis. Means finally I have travelled a distance of Fx plus Gx along x-axis. Therefore, I can write it is Fx plus Gx along x-axis, that is I cap, plus I have travelled a distance of Fy along y-axis, I have travelled a distance of Gy along y-axis, and effectively I have travelled a distance of Fy plus Gy along y-axis, and similarly I can write it is Fz plus Gz along z-axis, that is along K cap. Means this is the addition of vectors if they are represented in their component form. Correct? Fine. Now what is the subtraction? We are aware about the meaning of the subtraction. Subtraction is nothing but addition of its complement. Now what is the complement of the vector? Suppose A bar is there, and if I will have to write minus A bar, that is complement of this vector, just I will have to change the direction of this vector. Therefore, if A bar is A into A cap, then minus A bar will be A into minus A cap. Only there is change in the direction. Direction is to be flipped. And therefore, if I will have to if I will have to subtract Q bar from P bar, then what I will have to do? I will have to add Q bar minus Q bar in P bar. Okay, therefore what I will do? I will draw a p bar here. This is my vector p bar as it is at previous. And now instead of using this q bar for the addition, I will draw minus q bar, correct? This is minus q bar, and I will add p bar and minus q bar. Therefore minus q bar will be somewhere here. This is minus q bar. Either I will use the triangle law of vector addition by drawing the q bar here, or I will use the law of parallelogram by drawing the q bar at the same point. Now this can be homework for you. You can draw two vectors p bar and q bar, or m bar, n bar, etc. You may draw them on the paper. Then you may flip the vector n bar and then add it, either by using the triangle law of vector addition or by using the parallelogram law of vector addition. Therefore, I can say that p bar minus q bar, here it is s bar is equal to p bar minus q bar. Now I cannot use the letter r because r is the addition of p bar and q bar. Therefore, I have used the letter s. It is p bar minus q bar. Therefore, this can be treated as the p bar minus q bar. Same thing is possible in case of the component representation of vector addition. Here if I assume that f and g are the vector, if h is f plus g, but now I will write the minus here itself, here it is minus, therefore it is f bar plus or minus g bar. Here also I will write this g bar in bracket and I will write here it is plus or minus. Similarly here it will be plus or minus, this plus remains as it is, here it is plus or minus and here it is plus or minus. Means in case of the vector addition or subtraction, in component representation there is addition or subtraction of their components only, correct? And the unit vector remains as it is. Now from this point onwards it is possible to have some homework. Therefore the first homework you may do, draw any two vectors. Let this is the vector a bar, you may draw as you want. Draw one more vector, say for example b bar, as you want, of different magnitudes, random directions, etc. And for you there will be a homework with help of the triangle law of vector addition. Find a bar plus b bar and a bar minus b bar too. Though it is known as triangle law of vector addition, subtraction is also possible with help of the triangle law. Do it. In case of any doubt, you may contact me. Similarly, you may use the parallelogram law of vector addition for addition of a bar and b bar, and obviously for the subtraction of a bar and b bar too. This is one homework. For the second homework, write down two vectors. Let m bar is equal to 4 I cap. Now I will be giving you the actual vector, that is 4 unit along x-axis, minus 3 unit along z-axis, that is y-axis, and plus 1 unit along z-axis. N bar is equal to, say for example, 3 unit along z-axis and plus 2 unit along z-axis. Now using this m bar and n bar, find the resultant of their addition. Obviously here the vector is represented in component form, therefore you will have to use the component law of vector addition and subtraction and find the difference between, or the subtraction of n bar from m bar, that is find m bar plus n bar and find m bar minus n bar. It is fine. Thank you.